When you learn electronics, you inevitably program a liquid crystal display, or LCD. For this project, we are using a 2-line 16x2 LCD. We'll use dip switches to initialize the LCD, sending instructions and commands. It isn't as efficient as programming it with a microcontroller, but it's a good lesson in learning what is involved to display data. Here's the dip switch we are using. It has 10 switches. We're using the LCD in 8-bit mode, so we're only going to use the switches to send 8 values. It's a straightforward process to set the dip switches. Next to the switch is a button. We've connected the LCD to the enable pin to send the values of the dip switches. Down here is a potentiometer. This LCD allows for the adjustment of contrast. We'll demonstrate this later. Above the dip switches is the pull-down resistor. When the dip switches are set to on, the path of least resistance is to the LCD. If you look closely, you'll notice that it has 8 pins. We use it only to send data to the data bus. Now let's take a closer look at the LCD. Over on the right are the A and K terminals. A is the positive terminal for the backlight LED. K is the negative terminal for the backlight LED. And then we have pins DB0 through DB7, and these are the data bus. DB0 is the lowest order bit. It's possible to run the LCD in 4-bit mode. In this case, pins 0 through 3 are not used, but we're using the LCD in 8-bit mode. When we send characters to it, we convert the ASCII to binary and send data to the pins. There are lots of handy web pages online that will do this conversion for us. We'll demonstrate that in a few moments. Now the E pin starts data read and write. This is connected to our button. Our W is to set whether or not we're reading or writing. We're only going to write to the LCD. And then RS is the register select pin. We also have V0, which is connected to a potentiometer. VSS is ground and VDD is volts. Over here you'll see an LED. We put this in here for troubleshooting purposes. So you can drag the pin across the data bus terminals and see which ones are active. So we had a lot of fun learning about this LCD and programming it. So if you're ready to get started, let's go. Now here's the data sheet we're using. We'll put a link in the description below. But all you have to do is search on the internet for HD44780 and you'll get a lot of hits. Now there's a lot of information in this data sheet. It's packed with it, but we're interested in just one section, and it happens to be on page 43. And this table shows you how to initialize and send data to the LCD. So we're interested in 8 bits and 2 lines. So step 1 is simply to turn it on. Step 2, this sets it to an 8-bit operation and selects 2-line display. Step 3 will turn the display on and set the cursor, and 4 gets it ready to enter data. Now, step 5 is where we'll actually set the dip switches and send data to the LCD, and you'll notice that the RS pin is set to 1 in this instance. And then the data bus has the values in binary, and in this case they are writing the letter H. So we'll go ahead and do that too. So the easiest way to do this is to first find the value of capital H in ASCII, and we're going to convert that to hexadecimal, which is 48. Then we'll go to an online converter. There are lots of these online, and we'll enter the value 48, and here we'll get the binary value 0100 1000. So let's go ahead and input this into our LCD. Now one thing to note here is that on the LCD, the low order bit D0 is on the left side instead of on the right side. So what you'll have to do, depending on how your dip switch is wired, is to reverse it. So our dip switch number 1 is wired to D0. So in our case, you'll notice that we just reversed the dip switches, and then to send the data we hit the button. So here is the letter H displayed. Okay, let's go ahead and do another one. And this time we will do the letter I, and they have an example here. They spelled out the entire word Hitachi. We'll just use HI. So let's go ahead and look this up in the ASCII table. And then, yes, capital I is 49. And we'll go ahead and convert that to binary. There's just one change on the end there. So here's the letter I after we inputted it on the dip switch. You'll notice that we just changed pin number 1, which was the low order bit. Alright, now let's go ahead and move the cursor down to the second line. So you notice that on the command to do that here, the RS, the register selector bit, is set to 0. So go ahead and do that and then enter in the rest of the values. And here it is, down on line 2. So you got lots of room for data here. Now let's go ahead and demo the potentiometer. As you can see, you can adjust the contrast easily with the potentiometer. There we go. Alright, well, we hope this video inspired you to buy an LCD and program it. Now, this programming it with a dip switch is kind of tedious, but in an upcoming video we're going to use an Arduino to program it, and we're going to push it to its limits. So until then, thanks for watching. Till next time.